Okay, let's continue our class now.
Okular.
In this slide, we will introduce relational operators. Silly question: how do we compare height, size, length, etc.? For example, does David score better on the exam than Smith? Do elephants live longer than turtles? Is basketball as big as the Earth? In Java, we can use relational operators to compare height, size, length, etc.
Arithmetic operator.
There are many relational operators. For example, greater than, less than, equal to, not equal to, greater than or equal to, less than or equal to. For example, David's score greater than Smith's score. Elephant lifespan less than turtle's lifespan. And the size of a basketball equal to the size of the Earth. The relation operator's result is a boolean. The values of a boolean has just two values. One is true, the other is false. In what data type can be represented? Is a work of art real or fake? Is the starting time for subway line 2 at 5? Did you get a 90 on the exam? So in Java, a new data type, boolean type, is introduced. The boolean data type's value has only these two values. First is true. The second is false. See the question here. Import David's score from the console and compare it with Smith's score. Line output is David's score higher than Smith's. This is the code example. We declare an integer variable Smith score and assign a value to it. Then we declare a boolean variable is big. To store the comparison result. Attention please. In Java, we often declare a boolean variable start with the word is. For example, is big, is small, is longer, and so on. Okay, then we input David's score and store the value in David's score. In this statement, is assigned to the value of the expression David score greater than Smith score. After that, we output the comparison result. We store the comparison result into big variable. Operators. What's the result of the expression? In this expression, this is a remainder operate. This is a remainder operate. The expression 40 remainder 6, the value of 40 remainder 6 is 4. So 3 plus 4. 3 plus 4 is 7. And the right expression's value is 9 divided 2. The value, the result is 4. Multiply 3, so the value is 12 on the right hand side. 7 greater than 12. The result of the expression is false. So in this slide, we will introduce a important concept, precedence of the operators. In Java and C language, parentheses has the highest precedence. That means in an expression, we often compute the expression in parentheses at first. Lowest precedence assignment operate has the lowest precedence. The precedence order about other operators is shown in the box. Arithmetic operators is before relational operators is before logical operator. There's a useful tip. When there are too many operators to determine the order in which they are executed, you can use parentheses to control the order. This is a useful tip for we write an expression. Okay. This is a student exercise. Key points of this training: operators usage. And this exercise is today's homework. I will skip it. Println similar. Println receipt consumer list. This is the other exercise of this chapter. lucky draw. Okay, this is the homework in chapter 2. So we have 3 homeworks in this chapter. This is the 4th homework. Because this homework are too simple, so I will skip them. Okay. We will continue to chapter 3. In this chapter, we will upgrade the shopping management system to realize lucky draw function and member information input, the checkout function, and the calculation of member discounts. We will master the basic if statement, logical operators, multiple if statement, and nested if statement. See the question here. If David's score is above 90 on the test on the Java test, he will get an iPhone 11 as an award. We can use the if statement to solve this problem. If statement tells you program to execute code block only if a condition evaluates to true. The syntax of if statement is shown in the box. Attention please. The code block enclosed in brackets execute only if the condition's value is true. The code in code block may just one statement, or many statements, or several code blocks. The figure shown on the right side is called a flow chart. Flow chart. Which is used to describe the execution order of a program or a code fragment. In this flow chart, we can see a diamond shape. Diamond shape is represented a judgment or condition. And we can see some rectangles in the flow chart. These rectangles are used to represent the process, task, or some operations. We can read the flow chart by following the lines with arrows. The lines with arrows determine the flow through the chart. The flow charts are often drawn from top to bottom or from left to right. The condition often is a boolean expression. That means its return value is true or false. Note that don't omit braces, even there's only one statement. This is a good habit for a true program. In fact, if there's only one statement in the code block, you can remove the braces and the program can run normally, can run successfully, but this is not a good habit. So I strongly recommend that if there's only one statement in the code block, you should add the braces in the statement, in the if statement. For example, to solve the question mentioned before, we can use the if statement. If score greater than 90, system out print line, get iPhone 11 as an award. Let's see the simple one-way if statement. Okay, let's see the demo here. If just score greater than 90, system out print line. Give you reward. This code line is a wrong style. Don't worry about it. You can press Alt, Shift, and F to make it clear. Okay, test the program. If the score is 70, this statement will be ignored. If the score is greater than 90, then the statement in the braces will be executed. Note that 90 is not greater than 90. If we import 90, the condition's result value is false, so the statement will be ignored. We can also declare a boolean variable to store the expression. We can declare a boolean expression to store the comparison result. Okay, this is the if statement. See the question here. Sometimes we will meet some complex conditions. For example, if David's Java score is greater than 98 and his music score is greater than 90, 80, the teacher will reward him, or if the Java score is equal to 100 and the music score is greater than 70, the teacher will also reward him. There are many conditions in this question. How do we connect multiple conditions? We can use logical operators to solve this problem. There are three logical operators. First is logical AND. The second is logical OR. And the last one is logical NOT. The logical expression is listed in this column. First, logical AND. Condition 1, logical AND condition 2. Only when two conditions are true and the result is true. That means if condition 1 is true and the condition 2 is true, then the result of the expression is true. Condition 1, logical OR, condition 2, as long as one of the two conditions is true, the result is true. For example, if condition 1 is true and condition 2 is false, the result of the expression is true because just one of the two conditions is true. The result is true. Not condition. If the condition is true, the result is false. Otherwise, if the condition is false, the result is false. So the rewarding condition we can express as the following expression. Score 1 greater than 98 and score 2 greater than 80. Logical AND. Score 1 equal to 100 and score 2 greater than 70. Note that operator precedence order. Logical NOT is before arithmetic operators, is before comparison operators, is before logical AND and before logical OR. Maybe this expression is too complex to understand. I will show you how to understand it. Parentheses has the highest precedence order. We can see it in chapter 2. Okay, see the slide here. The highest precedence is parentheses. So the expression can be divided into two expressions. First one is we can add some white spaces to make it clear. And the second expression is the highlighted codes. Okay, then let's see the slides here. The comparison operators is before logical AND. So score 1 greater than 98 will be executed at first. And score 2 greater than 80 will be executed before this logical AND operation. Both this expression and this expression's value is a boolean value, true or false, true or false. Okay. And in the next expression, the same execution order this expression and this expression will be executed before logical AND. Both of them has a boolean value, true or false, true or false. And the logical OR, its precedence order is the lowest in this expression. So this expression's value is boolean value 2, and this expression's value is boolean value 2. Okay, let's continue. Here's a tip for this complex expression. If you don't know the precedence order, you can use parentheses to control the execution order. See this sentence. When there are too many operators to determine the order in which they are executed, you can use parentheses to control the order. In fact, this expression can write on If you don't know the precedence order, you can use parentheses to enclose these expressions. This will make the code clearly to understand. So it's a good habit. Silly question here. If David's Java test score is greater than 98, his teacher rewards him with an iPhone 11. Otherwise, the teacher punishes him with coding. We can use two if statements to solve this problem. For example, if score greater than 98, system out print line. Good job. Give you an iPhone 11. If score less than or equal to 98, system out print line. Write job code again and again. However, this is not the best choice. We can use if-else statement instead. The syntax of if-else statement is if condition is true, then the code block 1 will be executed. Otherwise, if the condition's value is false, the code block 2 will be executed. To solve question 3, we can use the if-else statement as shown in the right side. If score greater than 98, give you iPhone 11. Else write 9,999 code lines. Okay, then silly example, we use if-else statement to solve question 3. This is the whole flowchart for this program. In this flowchart, there's two rounded rectangle, begin and end. These rounded rectangle are represented the beginning and the ending of the program. Sometimes we ignore this rounded rectangle. For example, we create a NetBeans. We create a NetBeans project to show the result. Okay, score. Assign a value to it. If score greater than else, copy it. Okay. Run the program. Because the score is 90, its value is less than 98, so the else part of the if-else statement will be executed. This is this line. If we change the value, the score's value to 99, score greater than 98 returns true, so this line will be executed. Okay, this is a funny student exercise. Let's see it. Lucky draw. Lucky draw. A member is lucky if the 100th digit of his member number is equal to the random number generated. Output a message, then input a customer's number. This number is a 4-digit number. For example, 1, 2, 3, 4. 1, 2, 3, 4 is a lucky customer. If the 100th digit of 1, 2, 3, 4 is equal to the random number generated. Otherwise, it is not the lucky number. Okay. The implementation steps are shown in the following. Step 1, generate a random number. In order to generate random numbers 0 to 9, we can use this statement. Step 2, receive a 4-digit membership number from the console. Number 3, get the 100th digit of the membership number. Step 4, determine if you are a lucky member. Okay, let's do it now. Okay. Let's do exercise. If you finish this exercise, please tell me in WeChat group. Thank you.